Jennifer Finney, and this is my first physics lab for 2011, titled Constant Velocity of an Object. All right, so the purpose of this lab is to observe an object moving at a constant velocity without changing any direction. This constant comes from the ideas of Newton's first and second laws. Newton's first law states that an object in motion will stay motionless, acted upon by an outside force, in this case being frictional force. This is also known as the concept of inertia. Because a friction is always present with the contact of two objects, however, friction will be present in this lab, although for conceptual purposes and calculations, this force will be ignored. The momentum principle expresses that a net force of a system causes momentum to change over a period of time. This is later to be proven in the results of this lab. When the F net, or the net force onto a system is equal to 0, the object will continue to move at a constant velocity. To be at a constant velocity means that there is no change in the velocity due to the net force. The velocity update formula was chosen because it relates an object's current velocity with its momentum slash F net and change in time. For each time step, the object will move in the same amount of distance, which is on the position versus time graph will show a linear positive correlation between the two variables. All right, for this experiment, I used a jar of argan oil hair curling cream and it was rolled onto a flat wind surface into my dorm for about 3/4 of a meter. The initial conditions are listed below. So the mass of the object was about 0.45 kilograms. This position was about the origin, which was about 0.0003 in the x direction. The initial velocity was calculated to be 0.218 meters per second, and the absolute time was there at t equals 0 seconds. And the total time, as shown on the right, is 1.335 seconds. And the delta t, which is what I used calculations, was t equals 0.017 seconds. All right, and this is my video. On the right is my hand, and I have a jar of the cream. And it's going to be moving in the left direction over here. Let's watch this video. This is my system, the jar, and the surroundings are the floor, the ruler, everything outside of that. So let's play this video. All right, and I started this video, make sure it was at a constant velocity, waited for the jar to speed up, and then I pressed the record button. And as you can see in the video, there's a slight deviation as far as direction, moving in a little bit. You'll see that the tracker. Over here is my tracker observations. We have a purple x-axis, and we have these red dots, which is my time steps that I use for the tracking. The video is a little flipped over here, so now the orientation is where the jar is being on the right side. As you can see here on the bottom right, there is a y component, which means there was slight change in direction for the y hat component. But as you can see, overall, it's a pretty positive trend with very little change of direction and a very constant velocity, what you can see in these graphs over here in the results. But first, we have the code. My code over here is the starter code. At the top, we have the ball's initial position and velocity, which we stated before. And then I have while t is less than 1.335 seconds, which is the total time of the video. We have the F net, which is calculated as 0, which allows us to have a constant velocity. And this is also shown in these graphs over here. The results have a little 3D diagram of the motion of the object. And then we have the position time graph, which is a very direct and positive slope and correlation between position and time. And over here, because the velocity is the derivative of position, when you take the slope of the position time graph, you'll get a flat linear line for the velocity time graph shown below. All right, so any what ifs? So for the tracker video, I chose the purple axis to be in a positive direction because the direction of the jar was running to the right. So just be a lot easier just to have like right and then a positive x direction. However, this could have been rolled to the left. I just have to flip the x-axis to be in the negative direction. This rolling upwards, same thing, just have to roll it into the y hat. And what does this mean for purpose-wise? So obviously, there's a lot of small outside forces that can act onto a system. Unfortunately, because the human mind and also computing power is quite almost impossible, quite literally impossible to see and experience every single force acting onto a system at once. And for the conclusion, in short, while ignoring the force of friction, an object moving initially at a constant velocity will continue to move in that same constant velocity. To prove the procedure for a future experiment, minimizing the chances for the object to change directions while it's rolling is absolutely essential. Thank you for watching my video. Hope you have a good day.